In the previous video, we took a look at symmetric and asymmetric encryption. I shared HTTPS sites as an example of asymmetric encryption. While that is true, there is a little more nuance on how it works, which I am going to cover in this short video today. So let's get started. Let's assume that you go to medium.com and you see this padlock. So what do you infer from there? It's an HTTPS website. So these days, the browsers actually do not show this HTTPS, they instead show this padlock. So when you click on this padlock, it shows some details. One, it tells you that the connection is secure, and the another, it tells you that the certificate is valid. And when you click on this valid certificate, it will show you the details of this certificate, where the certificate has been generated for medium.com and it has been generated by Cloudflare company. So how do these certificates work? And how does asymmetric encryption come into the picture in all of this? So for that, we will take a scenario in which you named Rockstar are trying to access the server of unethical.in. Now, if you remember my LinkedIn post here from a few days back, I'm collecting the data for partners' moods from people, right? And let's say that uh, you actually want to share the mood of your partner for this research, and you go to unethical.in and you start filling out this form in which you put the age of your partner and the mood that they are in today. Now, there is a connection between your browser and the server. There is a channel open between these two. In this case, there could be someone from outside who tries to tap into this channel. This is also called man in the middle attack. The man in the middle attack means somebody else is tapping into the data exchange that is happening over a channel, and they are able to make note of this information that you have just shared with me. They know that Rockstar's wife is aged 45 and she is in good mood today. Tomorrow, maybe she's in bad mood. And based on those moods and based on who this person is, they may be able to carry out a fraud. For example, a credit card fraud. They call on the day when your partner is in a good mood and is more likely to share SMS with them. So this this scenario is quite common in the internet, and that's why when you go to banking websites, you will generally see this padlock and all the security mechanisms. These days browsers actually also uh, do not allow you to access the sites, or at least prevent you in the first place from accessing the sites which they think are not secure. So how does all of this work? Now, what happens with HTTPS? So this was the scenario when this is in HTTP. But lucky for you, when you go to http.unethical.in, because I am currently redirecting this to a Google Forms page, that Google Forms page is actually using HTTPS, and you are actually filling out the information in a secure way. But how does this work? How does HTTPS work? Now, consider the same scenario. You have your browser and you have the server here, the browser here and the server here. The server, because it is HTTPS, it has the key, and it has access to asymmetrical keys. So it has a private key and a public key. What it does is it copies or it shares its public key with the browser, with the client, right? So the client gets a copy of the server's public key, and then it sends some information wrapped in that public key back to the server. This initial process is called the TLS handshake. During this TLS handshake, they also generate a session key, which is basically a text string and generated from some random data. Similar to, if you recall, in the last video, we generated a key which was a simple number, In this case, it is a little more complex than that, but it's basically a single key which is available with both the browser and the server. So they generate this key and then they share this. So this key is actually generated on the browser side. So it wraps this randomly generated key in the in the public key that it has. So it wraps some random generated data as it wraps some random generated data in the public key that it has and shares that with the server. So now server is able to use this private key here in order to decrypt this data. So when they decrypt the data, now both of them have this same random text that they can then use in order to encrypt the further communication. So after this step, after the initial TLS handshake step, they fall back on symmetric encryption, which we studied in the last video. So now you have the same key with which both the browser and the server are encrypting and decrypting the data. And this key is valid only for that session. So it's also called a session key. So during that session, any data which flows between the browser and the server. So let's say the browser sends some data, it will wrap that with the key that it has generated in the previous step, the session key that it has generated. And because server also has access to this new session key, it can decrypt and see the original data. And whenever it needs to send any communication, it can use the same key in order to send the data back to the browser. So anyone who tries to tap on this channel here sees information which does not make any real sense to them without any key, right? So they have that's kind of garbage for them unless they have access to this session key through which they can decrypt the data. So I hope this video gives you some idea into how your browser and servers communicate over the secure socket layer, or also called TLS encryption. Thank you. Let me know your thoughts in the comments, and see you in the next video. Thanks a lot. Bye bye.